Today, I'd like to talk about how Istio has helped in troubleshooting the microservices we operate. I'm Shota Shirayama from Japan and working as a software engineer at Rakuten. Rakuten is a company that runs several businesses such as e-commerce mainly for Japan. Okay, let me start my presentation. Today's session aims to make those who are currently considering service meshes think Istio looks good by presenting the actual story that Istio helped us investigate on our microservices. The content is not advanced, but I would like to talk about a specific experience as one of Istio user. First, I'd like to explain our background. We run microservices, and it is generally said that microservices increase the complexity of the system. Without system observability, it will be challenging to grasp the overall picture of where and what is happening and how it is connected. One of the biggest concerns is that it will be difficult to isolate when a failure occurs. Our team had a situation where the development team was busy developing features and couldn't afford to improve logs and architecture. Therefore, the SRE team decided to use Istio, which can be installed without changing the application, to counter this system's complexity. Istio has improved the observability of the system and also expanded the range of network-related tests. Today, I would like to talk about how these benefits of Istio have helped us isolate complex system failure in our microservices. First of all, here is a simple system diagram to help you understand our system's outline. Main service and each microservices were combined to configure the backend on GKE with Istio installed. Main service uses GraphQL. Main service receives a user's request and call each microservices, but there are some places where some microservices call main service. As you might know, when we install Istio, Istioproxy is deployed as a sidecar container together with each application. Communication between services will be performed via these proxies. Istio will provide various functions such as authentication, encryption, and logging or monitoring at this layer. No application changes are required to install Istio. From now, I'll talk about a failure that happened to our system. One day, one worker node on GKE went down due to a network failure. One part of redundant main service was running on that node. The node and parts recovered automatically after a while due to Kubernetes and GKE's auto-healing mechanism. After the automatic recovery, both node and pods were running normally. So we thought our application ran correctly, but unfortunately it didn't. One of main service endpoints has stopped responding. This endpoint calls service A internally. Since service A wasn't directly affected by the node failure, the situation looked very mysterious for us, and we couldn't find the root cause of the problem at that time. We decided to restart the service A part manually. Then the problem disappeared after that. The facts so far did not tell us what was happening. Service A did not have an access log, and the application log did not output useful information that could identify the cause. It's not only for microservices, but the lack of useful log information is fatal in this kind of system trouble. Next, we checked Istioproxy's log, and we found abnormal records when connecting from main service to service A. There were a lot of upstream connection terminations when the service A part restarted. In other words, main service connected to service A and waiting for a response long time, then disconnected by restarting service A. This response flag, logged in the Istio proxy, often gives us valuable information about what was happening at the time of the failure. With this, it seems that we could dig a little deeper into the cause of the failure. Next, we made a hypothesis about why service A could not return a response to main service based on the processing flow of main service and service A. Service A consists of API, in-app queue, and single process daemon. First of all, the node running main services went down, and probably the processing of the single process daemon was waiting for the response from main service. In that case, since the queue data is no longer consumed, it is considered that the app's queue gradually became full and the processing of the API of service A, pushing the data to the queue, was also waiting. As a result, service A's API may no longer be able to return a response to main service. Both main service and service A didn't have the proper timeout settings when calling the API, so this hypothesis was entirely possible. We made a hypothesis, but we haven't verified it yet, so we tried to reproduce the same situation in a testing environment. However, when we tried it, it wasn't easy to cause the same situation. We wanted to reproduce the situation where main service does not return a response to service A, so we thought we could use Istio's fault injection function. Fault injection is a feature that can return an error or cause a response delay at a specific rate in any HTTP connection without changing the application. Using this Istio fault injection feature, we set a fixed response delay only for requests from service A to main service. Then, as expected, data gradually accumulated in the queue. The API of service A also became waiting. As a result, we were able to reproduce the situation that main service also became waiting. This reproduction procedure using Istio proved that the hypothesis made earlier was correct. In summary, in situations where it was difficult to identify the cause from the app log alone, the proxy log provided by Istio allowed us to make a hypothesis about the cause of the failure. Using the function provided by Istio, we were able to reproduce the failure in test environments. Today, I talked about how the functions provided by Istio were valuable in the actual system. I hope this experience of ours will be helpful to those who are considering the introduction of Istio. That's it from me. Thank you for your listening. Let's have a fun time for the rest of IstioCon together.